can begin. Okay, I think we are ready to get started. Already quite a good number of participants in the room. Thank you for joining us. And welcome to the session on circularity from methods to infrastructure. My name is Beatriz Alfonso. I'm a policy officer at the ERTRAC of the European Commission. And I'll be moderating this session together with Gladys Morac and Jem from Renault Group, who is a pollutant footprint expert and part of the circular economy teams. So before we dive into the presentations, let me kickstart this session with some contextualization on the topic, which I believe many of you will know very well, and also looking at the current Commission's agenda, that circular economy is no longer only an environmental objective to be achieved. Circularity has been now pushed into the core of what is the strategy for competitiveness in the EU. It's linked with reducing our import dependencies on raw materials and that we need to produce clean technologies. It's also about lowering costs of production and about strengthening European value chains to help maintain our global industrial leadership. The high-level challenges are already quite known, and this was even highlighted yesterday during the opening session by one of the panelists who really highlighted the need at the moment, the most urgent need to have a business case for circular economy in order to make it more mainstream, and the need to address the current pitfalls on costs and infrastructure who are lacking to be able to create this full circular economy system in the transport, in the mobility sector. And to make this a reality, we need targeted innovation. We will need better tools to make circularity work in practice. Both on the policymaker side and the industrial stakeholder side, there is a clear need for reliable and harmonized methods to measure environmental impacts in a way that is comparable. We need also better transparency tools for traceability as well, like the digital product passports, to gather data and to keep better track of material flows in a supply chain that is very complex, and this for critical raw materials, but overall for all materials, because all of them have actually a part to play in the production of vehicles, and from production to the use, the reuse, and all the way to the point where it becomes waste, there is the need for this type of tools to help decision making. The automotive sector is already a front runner in circular economy. Now, with increasing shifts to electric vehicles and the increasing demand for batteries, we really see the need, also in the context of the recent EU legislation that addresses the life cycle of vehicles, that only makes it more crucial right now to really nail down this formula, if I can call it like that, to make electric vehicles fully circular from the very design stages. But also important, and to not be forgotten, that circular thinking must extend also to infrastructure and this type of long-lived assets, which is sometimes easy to overlook or has been more overlooked. And in that context, it's important to ensure that transport systems are designed and managed with life cycle thinking in mind from the very beginning to reduce material use, the emissions and the costs over the time. So for those that were here last year, you may recall that there was already a dedicated session with this same thematic that tries to link together aspects of the infrastructure, the maintenance, but also the production of vehicles as such. Some of them have already presented some results at the time, so it will be interesting as well to see how these projects have evolved in the meantime. We'll have 4 projects to present today in this session, and I'm very much looking forward to better understand what solutions they're putting forward to address the challenges. So just one final remark before we jump into it regarding the questions. If there is any immediate question for clarification, that can be addressed immediately after the sessions, the presentation, sorry, but really questions for discussion where we go more in depth, these should be all saved for the end of all presentations. And I think with that being said, let me introduce our first speaker, Thilo Bein, Head of knowledge management at the Fraunhofer LBF for the presentation on TranSensusLCA projects.
So, thank you very much, Beatrice, for the kind introduction. Also, warm welcome from my side. Yeah, my name is Thilo Bein. I was the coordinator of the support action TranSensusLCA. Yesterday and today, I have seen many product presentations where lifecycle assessment was also a task. It's a very important task in, let's say, environmentally friendly technology developments. And when we were setting up the strategic research innovation agenda for the 2.0 partnership, we recognized that the methodology, the approaches, the assumptions are not harmonized, and depending which approach you are choosing, which assumption you have made, the outcome is different. So the outcome not necessarily is comparable. Thus, we decided to launch a support action to really work on a framework to harmonize the lifecycle assessment for the automotive sector. And this is the support action TranSensusLCA, which has finished mid of last year, actually end of June, and the results are now fully available. So, following the given template, as said, the TranSensusLCA objective was to develop a commonly accepted and applied single life cycle methodology for zero-emission road transport. We had different focal points. On the one hand side, we conceptualized and demonstrated such a life cycle assessment methodology using real-life data. We also elaborated on the ontology and the framework for life cycle inventory database. We conceptualized the life cycle inventory data management, so we also really addressed the issue of the data. The quality of a life cycle assessment strictly depends on the quality of the data, not only, but mostly. And we tried to bring this together to a consensus with all stakeholders relevant for the automotive sector. We were a quite big consortium. We had 11 industrial partners and 9 research partners representing the full value chain needed for zero-emission vehicles, including the battery sector. This call actually was a joint call between the 2.0 partnership and the BEPA partnership. At that time, I think it was the first joint call in Horizon Europe. And due to the high interest, we decided to also have a big group of associated partners. Altogether, we were 24 associated partners. And on top, we established 2 advisory boards, scientific and industrial advisory boards, so that altogether we had more than 60 stakeholders working on the elaboration of this LCA framework. And I think we reached a quite good consensus among all stakeholders. The outcome is then being published in a consolidated guideline. So this guideline provides or gives a description of the standardized methodology. This methodology consists of 144 requirements for the environmental life cycle assessment, of which 59 of these requirements are mandatory, 54 are recommended, and 23 are optional, 8 informative. So you can see from this split that we try to reflect the different needs of the industrial partners, and that there are mandatory and optional and recommended possibilities as long as you make them transparent and if you can justify it. We also worked on a social life cycle assessment. Here we defined 51 requirements, of which only 15 are mandatory, still quite a lot, and 34 are recommended. In summary, it facilitates the decarbonization of the road transport system without really shifting the burden to other environmental compartments. And we also decided that this is a living document, so we will continuously update this document in the ERTRAC working group on circularity and competitiveness. I already put here the link. You can download this guideline and all other reports from the project through the project homepage. It's LCA for transport.eu, and we will always we always upload the actual version of the guideline, phrase it like this. Coming now to the result presentation. You can imagine if we have more than 190 requirements, I cannot go through all of the results we obtained, so I just selected a few results which might be of interest for you. One remark before, we acknowledge that implementation of a life cycle assessment can be different from industry partner to industry partner. So we have two levels of coherence or adherence with the proposed methodology. Level A, we defined that the assessment follows the full methodology proposed by TranSensusLCA, including the reporting. So all mandatory requirements will be considered and will be also published. And also that recommended and optional requirements can be followed. And level B defined that certain aspects for various reasons, for confidential reasons, can be excluded in the reporting. Nevertheless, all mandatory requirements will be reported, except including particularly those which are needed for public reporting. Certain requirements which are not needed for public reporting can be excluded, but all other bullet points are identical to the level A. Coming to the selected results. On the one hand side, of course, the ontology and data management is quite important. This is basically reported in deliverable 2.1. We can download it from our webpage. The ontology is following the proposed methodology coming from the Orient project. So we built up on existing work and we adapted it to the needs of TranSensusLCA. You see here some examples. There is a decomposition tree defined on vehicle level where you go into the different sub-assemblies and then break it down even further. And there's also a decomposition tree for the battery level that you can really follow and you can structure this. And then the methodology is composed of different building blocks. One of the building blocks is the goal and scope. It's the product definition and functional units. So we have considered different vehicle types, light-duty vehicles, heavy-duty vehicles. We also considered battery electric vehicles, fuel cell vehicles. What we did not consider are ICE-powered vehicles that comes from the nature of Horizon Europe. So the functional unit for the passenger cars and light commercial vehicles is basically the passenger kilometers. For the heavy-duty vehicles and lorries, it's a ton kilometers, and for buses and coaches, it's passenger kilometers. And we also try to consider two-wheelers. Here, the functional unit is a vehicle kilometer. As the default, we always assumed that the vehicles are driven with one passenger in case of passenger vehicles. In absence of a clearly defined vehicle segments definition, for the time being, we recommend to use an average vehicle lifetime of 200,000 kilometers, being aware that this is, for the time being, maybe not valid for all types of vehicle. However, once there will be a clear definition of the segments and we have more data, then we will update this to more realistic lifetime of the vehicle. For the heavy-duty vehicles, we are consistent with the vector-based assessment and fuel consumption. And for the power two-wheeler, we followed the ZEvRA model, which is provided or was provided by EMISIA. Looking into the lifecycle inventory, we considered the production phase, the use phase and the end-of-life phase. What we are not considered is, let's say, the production of the raw materials. This is something which, for instance, is covered by the raw material initiatives. We assume that the information are available on that part of the life cycle. Basically, within these boundaries, we considered the primary data requirements, the electricity and hydro modeling. You can imagine that this is something was discussed quite controversially. The multifunctionality was a big issue, and of course, the data quality assessment. Giving you an example, on the mandatory requirement, we have the production phase modeling, where we define the data requirements according to UNEDGE level 3, which is ongoing or should be published also very soon. We considered the electricity, energy supply, and distinguish between different modelings, and we also have defined different options you can choose from. And we also have then the use phase modeling, where you have energy requirements from the vehicles, on the electricity, WTT electricity and hydrogen generation. We also considered non-exhaust emissions and the maintenance consumables. And particularly for the modeling of the electricity and hydrogen supply, it can be done in different use phases. We propose a dynamic modeling approach informed by reputable energy future scenarios, and the end users can choose between different options, whether they're applying certificates or not. So this gives a certain flexibility without neglecting the comparability of the calculation. Another building block is the impact assessment itself. Again, here you see some of the mandatory requirements, impact categories. It's a greenhouse warming potential 100. We have the photochemical ozone formation, we have the acidification defined, we have particulate matters, anthropifications, and cumulative energy demand, resource use, minerals and metals, and the hydrogen emission flow. And you see on the right that some of these criteria are present in the environmental footprint methodology, and those which are present in the EF reporting are mandatory to be reported in both levels, are introduced before, and which are not present in the EF, they can be excluded if you choose level B. Coming to the impact, of course, we have now a framework which can be applied in a harmonized way. It has been developed together with all industrial partners, so that there's common sense. What we did within the project, we put the methodology really into real life and tested it with partners, so we call it road testing. And of course, there were some outcomes of the road testing which should be considered in future updates of the methodology. So you have to be very clear in defining the requirements and how you formulate it, because the requirements can be understood differently by different stakeholders. You have to be very clear in defining those requirements, which at the end I think we achieved. And you do need clear instruction how to go through a hierarchical level of calculation, and if you have different options to choose from, you need very clear instruction. And it also, if you want to repeat such a road testing, it is quite important to have a consistent approach and definition through all life cycle phases. The understandability issue with waste definition and multifunctionally needed to be solved due to different approaches. I think at the end, we revised a certain phrasing, so that is now solved. And we also learned that you really have to be sure with the wording that used consistently through all the guidelines. So at the end, we have a reviewed guideline, a commonly accepted guideline, which can be now used by the end user. So the impact is straightforward. So we, for the first time, I think we have a harmonized framework to conduct a lifecycle assessment in the automotive sector, and it can be used also then in the product development. And the outcome should be objective and comparable when you're following these guidelines. But we recognize that secondary data will be a key ingredient for the comparability, and I think there's still some research needed also on the secondary data. The benefits are straightforward. It will increase the user acceptance. It will, since it's transparent and it can be compared, the end user can really rely on the outcome, and therefore it's also supporting the uptake of zero-emission technologies. And I think also for the industry that we have now a common approach, it will decrease the threshold to uptake this approach in industry and in the product development. And it can also be used in future R&D projects to follow the strategy so that you can also compare the outcome of the different R&D project. With that, I can conclude my presentation. As I said, you can go to the project website for further information, or just get in touch with me directly, and I will provide you with the needed documents. Then thank you very much for your attention. I hope I stick in time.
Yeah, no, thanks a lot, Thilo, and congratulations on a project that was delivering very interesting results. Definitely a complex one, but I can comment that it brought together a very impressive consortium, and it involved a very big amount of stakeholders that are relevant, including at an international level. So it was very, very well achieved project results. I definitely encourage everyone to have a look in the websites at the published deliverables. But without further ado, I would like to introduce our next speaker and presenter, Justus von Frieden. Sorry if I don't pronounce it correctly. Research Associate at the Fraunhofer Institute, for the presentation on the ZEvRA projects.
So, hello. Thank you for the invitation from my side. I'm here on the behalf of Daniel Nabel. He's coordinating the project mainly, and I'm supporting him and presenting today the results of our ZEvRA project. Just to the beginning, the overall project presentation. We have in total 28 partners started in the beginning of 2024. Have a quite wide consortium, including 5 OEMs, suppliers, tiers, research organizations, and clusters and networks. Before I come to the mission and objectives in detail, just to make it short, the aim is to reduce the usage of virgin material in automotive production as much as possible. And therefore, we need a lot of puzzle pieces, and I try to highlight some of our first results during the presentation. We have different overreaching objectives, starting with a design for circularity methodology and circularity assessment. We have in total 8 use cases where we try to develop zero emissions solutions, and these 8 use cases representing 84% of the material mix of a car, and the objective is to minimize the virgin material. We're not just focused on material and processes, we also have a circular car concept based on our reference vehicle, the Skoda Enyaq. We are trying to fulfill the functional requirements and do a cost reduction for the disassembly in the end of the life. Besides that, technical solutions, we also address the awareness and acceptability of such circularity solutions and strategies. We have a virtual learning and educational platform, and we try to adopt circular business models for these zero-emission solutions. Now I want to go in the first results we have achieved in the first 2 years of the project, starting with our circular economy methodology. We have a design for this methodology, which is elaborated in the consortium during a lot of workshops, interacting with all our partners, and the next step is to involve stakeholders and industry from outside our consortium to validate our strategy or methodology and get more input. In that case, we have also the circular assessment tools with multi-criterial evaluation for material flows and with circular indicators. We did an LCA baseline, not in that detail as we saw in the previous presentation, but that we have a baseline from our baseline car where we have to benchmark our circular improvements during the project, that we have a comparison and see if we are on the right way. Starting with our use cases, on the metal side, we have a steel use case where the colleagues go to scrapyard and harvest some old roofs, did some depainting, properties analysis, and forming that into new fenders for our reference car. And in that case, that is supported by an AI tool, which is supporting the performance prediction. In that case, the colleagues did the case of a hood from a car with a head impact, and the crash simulations for the hood, where we have a lot of points where the head can impact, usually takes 14 weeks, and we now can reduce that with an AI tool to 1 to 2 days with a 99% reduction. And if we think on different material properties, various material properties to recycling or other topics, we have to simulate more. And if we can then save some time and save some cost, that's very valuable. On the other side, on our aluminum use cases, we have a casting, we have wrought aluminum and foamed aluminum. We have tested a lot of different alloys, castings, and now find good alloys to go in our production of the prototypes. And this is also supported with some digital twin for material and process simulation to get better results and be faster in the development. On our plastic and composites use case, we had the first organosheets made of recycled PET and GMT with up to 97% PCR content. That will go into a battery cover demonstrator. On really just plastics, we have ABS, PP, and PA6 with up to 70 PCR content, and all these materials are now qualified. We did the simulations, the testing, get the material properties, and now go into the production of the demonstrators, which will end up in our car. The last use case is the only use case we are not using recycled material, but we are trying to get innovations in the production, in the processes to reduce CO2 emissions as well as water. So we do some printing processes and laser cutting to reduce impact there. And the last use case is our rubber use case by Continental, where we have an entire with 45% closed loop recycled material, and the colleagues are actually on the performance test, safety and rolling resistance. Besides the topics of material and processes, we also work on the architecture of a car. And there, this is mainly done by ERTRAC and our OEMs. And we want to have standardized modules with a reduced material mix. If you see on the car today, we have a lot of different materials, alloys, and we have to reduce that to get less various materials to have better options in the end of life. So we have to develop joining techniques which are easy to disassemble, so that we can disassemble that big modules and then bring them to recycling or under end-of-life technologies. We did the body in white, as you can see here, and now the interior and exterior and wiring is the working goes on. Come to our stakeholder engagement. We have did some workshop and conferences and try to use formats like gamification and discussions to get input for our project, to get insights from the industry, and we want to build on that and want to go further with that we get more input if we are on the right way with our solutions. Our training and educational platform is launched. We get the first courses designed for our circular economy methodology for the aluminum recycling, and also there the other use cases and innovations should come to the platform. When I come to the expected impacts, I did some assumptions. If we see here on the left side, we go with reduction in the glass use curve of NML. We have now 0% virgin aluminum, high content of PCR plastics, steel repurposing, and 40% of recycled tires. And just to show which impact that can happen, we have here the EU EV market, and our 5 OEMs of the consortium cover at least 60% of them. And if we then say, okay, we can cover 84% of the material mix, that's the potential. I know that's a quite very good estimation, but just to show the potential. And if we then go through the different innovations, technologies, we can have a lot of reduction in saving of virgin material and in saving CO2 emissions. In the topic of economic and social skills, the transforming potential, we can save money in using secondary aluminum. We have a DigiPrime platform where we want to scale up for plastic recyclate and integrate second aluminum, and that is such a big market of materials, of secondary materials. They are traded and very, very high amount of materials. And using a digital passport for at least 12 million vehicles per year, that's also a high potential. Then we have our training, and we want to achieve at least up to 750 trainees in 5 years. And if we then use the trainer effect, everyone is train 5 others, we can scale up that and bring in the end more knowledge to the industry. In total, we have 420 stakeholders engaged now. We want to go further up to maybe 1,000. And in the end, if we can adopt the innovations, the ideas, we have a big market in the EU for 140 billion manufacturing sector with at least 2.5 million employees and 13 million vehicles per year produced in the EU. So it's a very big market, and if we can get there some innovations, some reductions in the use of virgin material, that can have a very, very big impact. So that's all from my side. More infos you find on our website or on our LinkedIn account. We have also some YouTube channel where we have some videos where at least the partners explain what they are doing in the project. Yeah, that's from my side. Thank you for your attention.
Yeah, many thanks, Justin, for the presentation. This is definitely very ambitious projects, and as I understand, we are now on the countdown, so there's less than 1 year to go until the finalization. You already shared some estimations, some very positive estimations on the impacts that can be achieved with the solutions of these projects, so I think now we're looking forward to see at the end of it, when you bring everything together, still with the elements that are missing, where do we land in terms of the emissions reduction and if we achieve the targets. That being said, I would like to introduce now on stage the next speaker, Farhadur Arifin, project lead and senior control engineer at Technovative Solutions, to introduce the base projects.
Thank you. So, I'm Farhadur Arifin from Technovative Solutions Limited. So, I am the project lead from the Technovative Solutions Limited and also the technical manager of the BASE project. So, BASE is all about creating the digital product passport, or that in this case it is the battery, okay, the digital battery passport. So digital battery passport, I think everybody knows this thing that by 2027 February, so this will be the mandatory component in all the batteries. Okay, so EV manufacturer or the LMT or the industrial battery which has a greater than 2 kilowatt capacity, they should have published the digital battery passport where the information related to battery related to circularity, sustainability, and the legal issues should be there. Okay, so the battery regulations, which is published in 2023, so it's already clearly given the data points, but still the industry still managed to try to understand what the data points and all other things. So based where we try to solve what are the data points, not only what are the data points, but also what should be the solutions, what should be the digital solution to capture all the data points from the mining to the recycler. Okay, so this is not a very simple task to do. Okay, so collecting the data, not only the data, but also how we can ensure who controls which data, what is the control, what is the ownership of the data, and all other things. Okay, so our main motivation of this BASE project is to give a functional solution for the battery passport. Okay, and which will enhance the resilience of the supply chains, and also it will give us the enabler for the circular economy. I guess. Next. Green one. Okay. So the outcome of this thing, so I'll explain about the objectives and then the result, impact, and the conclusions. So in the BASE project, we have 19 partners with 12 countries. Okay, so it already started. So we are in the month 20 now. Okay, so most of the digital tools we are implementing will be submitted by the Commission by these dates. Okay, so in the month 26, and then we'll start validating these things with our battery use case partners. So we have 4 use case partners. Okay, so one is Mercedes-Benz, where we are trying to develop the batteries develop the digital battery passport for their bus, and also the Ford, where we also develop the battery passport for their EV. And we have a marine battery, which is a very interesting use case, okay, so which is a little bit different compared to the EV batteries. So when we are talking about the battery passport, we are already always thinking about the maybe EV batteries, but marine battery is a little bit different, and also they have different regulations for the marines, okay, so we have to also include those regulations and also the battery regulation and also the ESPR regulation to combine, so that it will be the battery solution will be compliant with the battery regulations. So, and then we have another use case, which is the industrial battery, but it is a second use case. Okay, so it's a second-hand batteries. Okay, so we have a EV batteries, and it will go to the industrial battery or energy storage systems. Okay, and then how we can link our first battery passport to the second battery passport. So this kind of regulation, how we can comply with these things, we'll deal with these things in the fourth use case by B-Planet. And it is a 8.9 million estimated project cost. Okay, so that's it from the informations. And also it's a RIA project, the IA project, so we'll extend the technology level from 5 to 7, but our target is not only 5 to 7, but also we will try to extend our battery passport to TRLs 8 or even 9 at the end of the project. Okay, so objective, so if you see, so battery passport is the main objective, but to give the solution, what should be the underlying architecture of the battery regulation. So what we understand is that we need an interoperable framework and platform. So what does it mean by interoperable? Interoperable is a semantic interoperability. Different industry and even in the battery, different people are using different semantics. Okay, so we have to have a common common vocabularies to do these things. So our team is already working on the ontologies of the battery, so that the interoperability will be ensured. Not only these things, we are thinking about the data space to introduce so that the sovereignty, security, and are ensured. Okay, so and everybody, so all the use case partners know who is controlling which data. Okay, and then battery regulation is, of course, is a battery passport is coming from the regulation, but we don't need to focus on only the regulation. So how the industry will unlock this data from the battery passport and create some value with these things. In order to do these things, we are also introducing some of the tools. So one is the AI tools, where we try to evaluate the remaining useful life of the battery, which is very important for the second life battery uses. And also we try to introduce the circularity indicators. So here the OEMs or the manufacturer can able to understand what is the potential of the circularity of that battery, or even the recycler can understand, or the second-hand user can understand the potential of the circularity, and in order to, and then they can repurpose this battery in other industry. Then we also develop ESG indicators. So ESG indicator, economic, social, and governance indicators, so which is very important, because one of the important data points for the DBP is the due diligence report. So here we have to provide the ethical sourcings for all the use case, all the actors in the value chain. Okay, so I think the ESG indicators can evaluate the organizational ESG practice. Okay, so it will help them to develop the to quantify or to integrate the data, not integrate the quality of the data for the digital battery passport. And for the business model, we already have a business models. Okay, so for each use case partners. Okay, so we submitted the business plans, okay, so as a deliverable, okay, and we will, yes, okay, so results. So if we see here, so these are the different tools we have proposed in our base project. First one is the base data space and portal. It is the data space is completed. Okay, so I will explain more about these things. And DPP solutions. So the DPP solution, the app is developed. Okay, so I can also show you the QR code here. Battery circularity calculators, it's also completed. Okay, so we'll explain this one. ESG indicator and the scoreboard toolkit is completed. So we are now also working on LCA tool for batteries. So LCA tool, so in the GRC, they already give us the methodology for the LCA for the batteries. Okay, not only for the industry but also for the EV. Okay, and then we try to follow that one. Okay, so they have the block diagrams and the system boundaries and all, what should be the primary data point and what should be the secondary data points. Okay, and it should be in the PEF methodology. So we try to develop a tool which will help the EV battery manufacturer or the industry battery manufacturers to perform the LCA tool more efficiently rather than just go to the CIMA Pro or the Open LCA. And then, of course, we have some AI-based tools like AI remaining useful life predictors and the AI business analytical tool to promote the business in the promote business for the use case partners. Okay, so for the data space and attributes, we already said that in the data space we need a trusted and interoperable identity and access management. We need the verifiable legal entities and business partner discovery. These are very important for developing, for sharing the data across these value chain, battery value chains. Okay, so if there is no trust, then they will not share the data. It's not like one person will control all the data or one organization will control all the data of the DPP. Okay, so sharing, how it will be shared. So in our proposal is to develop the data space where all the value chain member will be onboarded, okay, and then they will share their data through the EDC connector or through the data space connector, okay, with a specific contract agreement or the smart contract. So that's the main point for introducing the data space in our digital battery passport solution. Okay, so this is the block diagram of the data space. Okay, in the bottom you can see the core component for the data consumer and the core component for data providers. Okay, so this is one of the challenges, but we have to overcome these things. So we already discussed with our use case partners that the IT infrastructure should be little bit adapted so that they can own their data and they have their own data storage where they have their digital twin registry and also digital twins. Okay, from there they can communicate and they can share their data. Okay, and of course there should be portal services and identity provider service and access management or semantic services. Semantic services means that the ontology and semantic interoperability should be there in the platform. Okay, so it's not like we are building the new data space. Okay, so it is based on the IDS and GAIA-X principle, but mainly we are following the Catena-X, which is also based on the GAIA-X principle. So we'll develop the data space based on the Catena-X architectures, and these are the 5 core elements for the data space. So now, if I just go to the data points, okay, so already in the other initiatives, they have selected some of the core components or core data points in the DPP. But we evaluate all these data points, and also we see that for different industry Okay, so the data points might be different. Okay, so marine battery and the EV battery and the industry battery, their data points will be different, and some of the data points which are saying the mandatory, it might be optional for the other industries. Okay, so this could be a recommendation to the EU, so that we can say that what data point should be mandatory and what should be it's not. And regarding the granularity, so in the granularity, like whether the data point should be the the battery models or the individuals. Okay, so it could be different for different batteries. Static data and dynamic data. So dynamic means that during the life cycle of the battery, we have to update the data. Okay, so how we update the data? So from the BMS data. Okay, so from the BMS data or in some other infrastructures. Okay, so we have to update the data. These dynamic data is really crucial. Okay, and how it, so infrastructurally, how we will connect these BMS data to the digital solution provider. We are working on these things. Okay, so the solution will be provided maybe in the month 30. So now we are in the month 20. Okay, but for EV, it could be simpler, but for industries or LMT battery, it could be a little bit different because their BMS are different compared to EV. Even if I talk about the EV also, the ownership of those data, which will be updated in the digital battery passport, it might be different. Okay, so there will be some other issues here, but technically it is possible. Also, access rights. So regarding the access rights, so we have the public access. Okay, so and the people with a legitimate interest. Okay, person with legitimate interest, and there should be private data. Okay, so there are 3 or 4 kind of accessibilities there. So it should be also in the DPP solutions. Okay, so we consider all these data points and we have finalized the data points for the EV and also for the marine batteries. For second life batteries, we are still working on that because there are a lot of data points which are missing from the first life. Okay, so maybe if we have a fast battery passport, then it will be easier. But at the very beginning, we are trying to develop the second life batteries. It will be a little bit challenging, and some of the battery mandatory data might be missing. Okay, so we are also trying to do some recommendation about these things. Oh, sorry. Okay, so I'll go just, if you see here, so there is a QR code. You can also check the DPP for the marine batteries. Okay, so I'll not discuss about these things. Circularity calculator is already done. Okay, so we are considering for the batteries, we are considering 4 metrics, which is material circularity, durability, disassemblability, and repairability. So in the material circularity, we are also considering the recycling component or recyclable component materials. Okay, so this is and also we create a score by taking the weightage of all these key metrics. And also for the ESG index, so we follow the principle. So our Geneva Institute developed this ESG index, and also the toolkit is done by ERTRAC. So time is up. So for the scientific and technical impact, so last 3, so we already developed the circularity index, we have developed the ESG indicator, and we have developed the data space architectures. For other 3, which is also important, like state of charge, state of health, and remaining useful life, and state of safety. So our research team are doing this thing to harmonize all these indicators, which are the important indicators and which indicators should be in the DPP, and what will be the methods for those. Okay, so hopefully we'll get the output by month 26 or something. and for social environmental impact, so enable the 4R decision making, support second life and remanufacturing, reducing the waste and critical raw material around demand. Okay, so improve safety and accountability in high impact sectors. And these are the impacts. I think the time is up. So that's it from my side. The conclusion is that we have developed the data space. We have developed 3 tools, so ESG indicator, circularity calculator, and the DPP solutions, and also base already demonstrate strong impact across technical, scientific, social, environment, and the economic dimension. So thank you very much.
Thank you very much, Farhad, for this very interesting, comprehensive presentation. This is actually one of those projects where there is a very close link between R&I and EU policy, so definitely an interesting one to keep an eye on for the sake of the batteries regulation, which also was re-emphasizing the automotive action plan, how the importance of sharing information and battery passports will be linked with the developments there. But without further ado, I would like to introduce our next speaker, David Garcia Sanchez, who is the principal researcher in energy, climates, and urban transition in Technalia, to present the liaison project. Yeah, there we go, that's the right one.
Yeah, so thank you very much for the introduction and for the invitation. First of all, I would like to say that I think this project liaison is like the weird beard of the roundtable that we have today, because the rest of the projects are talking about how to decarbonize the transport sector, but not from the infrastructure, but from the automation and from the vehicle aspect. So liaison is focused on lowering transport environmental impact along the whole life cycle of the future transport infrastructure. And as I said, we are mainly focused on the decarbonization of the infrastructure, promoting different solutions developed by the partners that I'm introducing right now. So as you can see here, we have a very talented value chain composed from construction and consulting companies such as Acciona, RDS, Orina, industrial partners such as Citron or Vita from Italy, also different RTOs, Technalia, that I'm representing, École de Pont, ZAG, University of Cantabria, and University of Vigo, and different owners, operators, and validators like MITMA in Spain, Autostrade per l'Italia, Prominent Institute in Slovenia, etc. The total budget, 5 million. And yeah, also really important, the icons, our colleagues from Italy, mainly focus on exploitation and dissemination. The project is promoting solutions not only for roadway, but also for railway, as we'll see right now. Yeah, liaison is built on 4 main pillars, as you see here. 4 main objectives, let's say, in minimizing the consumption of resources and reusing the available ones, evolving towards a prosumer infrastructures, and finally promoting and developing actions to facilitate market uptake by supporting procurement, legislation, and standardization processes that will help us in bridging the gap from the technology to the application. So I'm going to present right now the different results that we are clustering in the project, as you see. The first cluster is for the circular solutions. In this regard, we have, first of all, the bioasphalt. The bioasphalt solution is, as you see here, this is a video. I think it's a good idea after lunchtime to take a look to it. And just to give you an idea about the solution we are promoting here. In this regard, I can tell you that this is a validation that has been recently developed. As you see here, 13 January. And of course, we have different lessons learned right now. And as you can see here in the third point, due to the windy conditions during the laying and the compactation, we found some problems that at the end reflects some cracks that we are repairing right now. My colleagues are repairing right now these cracks that happened during this process. Yeah. Continuing with the circular solutions, we can talk now about these solutions developed by our colleagues from Slovenia. It's the low noise and vibration railway circular track, sorry. And yeah, this solution is a real needed one because in Slovenia they have some problems due to the low quality of the ballast. So they thought in including some recycled ballast aggregate and also some scrap rubber from recycled waste tires to reduce the vibration and improve the dynamical behavior, and also just to improve the quality of the ballast. Also, they developed this ERTRAC, as you see here in the bottom of the slide. That is a solution that has been patented, and the idea is to reduce the noise and minimize the vibration ballast railway track in combination with the previous mixed solution for the ballast. So we guarantee the 100% of reutilization of the construction materials. We reduce in a big number the permanent deformation of the ballast track, and this is something that is going to be tested in the next days. As you can imagine, bearing in mind the weather conditions that we have now in winter and also in Slovenia. The second cluster of solutions are the ones that we call the industrialized solutions. Yeah, there's another video. So these industrialized solutions are mainly based in a new recycled concrete for building slabs that have also embed a weight in motion system, and also a new design for beams that reduce the total amount of consumption of concrete itself in more than 30%. So yeah, we talk here about digital twinning, in particular in this solution, because we made use of digital twin for two different phases in each solution. So regarding the concrete slabs, we embed this WIM system, and of course we have a digital twin to be used when the solution is put on place, and detect when the damage is appeared and so on, and to make an optimization of the maintenance system and disassemble and put another one and so on and so on. But here we include also a new approach for the digital twin that was just for the building of the beams, because as you see here, these beams has a special design with many holes that needs a very specific control of the geometry, just to design and tailor the specific formworks that we need to use to build the beam at the end. Yeah. So we include the digital twin from the very beginning. Also, we install some different sensors embedded in the beams just to guarantee quality assurance and quality control conditions. And yeah, this solution has already installed in Spain. The third cluster of solutions is the one that we call the smart operation and maintenance solutions for transport infrastructure. And the first one is the one focused on the energy optimization. This solution is based on the development of a digital twin for a tunnel, a real tunnel in the Basque Country in Bilbao, in Spain, sorry. Yeah, the idea is to optimize the consumption, the energy consumption due to the tunnel fans and the lighting systems. So thanks to the collaboration with our colleagues from Citron, we developed a new digital system to trigger the energy demands, reducing the consumptions when necessary. And also regarding the lighting system, yeah, we include new scenarios to improve the current standards that we have right now in Spain and all around Europe, trying to optimize the energy demand and the energy use of this electricity. Another solution that we have developed in the project is the one we call the artificial intelligence power pavement distress detection tool. The main characteristic of this solution is that we are capturing a video making use of these gadgets that you see here in the slide on the top right. And well, it's quite efficient because we can take some videos very quickly. We don't need to, very quickly, I mean, driving 30 or 40 kilometers per hour, which is a really interesting solution because you don't have to stop the car on the road and disrupt the traffic. So it gives us the opportunity just to take images very quickly and a big amount in a very short time. So the tool was deployed to an external server to allow full operational and central management. Has been validated in Spain as well, and right now the ministry is double-checking with the recent results just to be sure that that the solutions that we are providing are as realistic as they thought. Yeah, here we're including some KPIs that have been also proposed by the ministry, but I think the relevant ones will be explained later on. I would like to mention that in this presentation, as you can imagine, due to the characteristics of the project, as you see, we have many solutions. We are developing different solutions for the transport infrastructure sector, for road and for rail, some other mainly focused in circularity, some others in modularity, and some other in operation and maintenance. I kindly invite you to participate in our workshops. The 5th of them will be the next 23rd April, and of course to the final event in 2026 that will be celebrated in collaboration with our sister project, Circuit. Regarding the expected impacts of the project, I want to mention regarding this that for the validation, for the assessment of the impact of the solutions, we have developed a very general framework from the very beginning of the project in accordance with the different levels of strategies coming from the building sector, and they are very spread all around Europe, trying to promote a unique strategy in terms of KPIs to be followed from the procurement process till the dismantling of the infrastructure. This is something that has been successfully implemented in the bioasphalt implementation, and not only for the development of a tender process for a project, but also for the tender process for the construction and for the technical assistance. Right now, the ministry is really happy with the results that we have reached, and also Rijkswaterstaat has contacted us just to keep informed and to be informed about the process that we've developed. In this situation right now, we are, as you have seen during the presentation, we are mainly involved in the demonstration of some of the results. And of course, we are assessing and taking all the values right now. And the idea is just to show the conclusions in the close future, and to be shared with all the audience, of course. So, yeah, this is the presentation that we prepared about liaison, and thank you very much.
Okay, so thank you, David. Thank you for all the speakers, and taken together the 4 projects showcased in this session. This illustrates how the circular economy is moving from principles to practice across Europe's mobility and transport systems. And I think that we have seen with TranSensusLCA that it provides the harmonized method and share metrics that are needed to access circularity consistently. Then with ZEvRA, we demonstrate how circular design and material loops can be embedded into next generation electric vehicles. BASE builds a digital infrastructure and traceability tool that is required to keep high-value materials circulating. And Liaison extends circularity into transport infrastructures themselves, proving that decarbonized, material-efficient solution can be deployed at scale. So now you better understand the title of this session, Circularity from Methods to Infrastructure. And collectively, this initiative shows that Europe is now entering a new phase of the circular economy, one where measurement, design, digitalization, and industrial deployment converge to make this circularity more viable and more valuable. So now I will open the floor for question. So please state your name and affiliation before your question. So I can't see you. Maybe we can have a little bit light in the room, please. But who wants to break ice? Yes.
Hello, Steve Marvin from PFA. I have a question for the BASE project concerning the compatibility with Catena-X BASE and whether you intend to roll out your product at scale on using the Catena-X ecosystem, because battery passport is one of the key topics for this initiative.
So our basic initiative was to create a data space with the help of Catena-X ecosystem. Okay, so we'll extend the Catena-X ecosystem, okay, or we adopt the Catena-X ecosystem, and also in the BASE project we are not onboarding on the Catena-X ecosystem. We can do these things. Okay, so this is one option, and second option is we are creating. So here, what we show is we create our own base data space, which is Catena-X ecosystem based. Okay, and where we are getting all these technical standards and all other things for the EV manufacturing systems. Okay, so this is the one options. Okay, so not the only options. Okay, so there are other initiatives where they are using some other options. But for us, we are thinking that data space should be the go for the digital battery passport. Yeah, thank you.
Thank you. Yeah, please, next question.
Hello, Riccardo Losa from Min Paris. I also have a question for the BASE project, and I was wondering to what extent did you involve, or you got the opinion of Chinese stakeholders, since they are not only the main producers of battery technologies, but also they already have their passport solution. So I was wondering if you consider them to make sure that they are on board when it comes to disclosing data about batteries, and also when it comes to maybe the interoperability between the European and the Chinese passport solutions. Thank you.
Yeah, so it's always coming, this question, right? So how we can deal with the China? Okay, so this is the different questions. Okay, but what we understand from the studies and all other things, they already created the DPP infrastructures from the Chinese point of view. So what we have to do from the EU is to connect between their ecosystem and our ecosystem. It's not possible that so one ecosystem will connect to the, so it should be something like that from the governance point of view. This is what we are thinking about.
Yes, please.
Good afternoon. So it's Andrea Superti from CINEA, European Commission. I have a question regarding the creation of a chain. So you proposed several solutions. What do you think is the time span if you want to create a chain for usage of this material? Do you see it feasible like in the next year according even to the experience that you have with stakeholders?
Is it?
It's to all the experts.
Okay.
Maybe liaison because it's more related to infrastructure.
Well, I would say that, of course, all the strategies or the policies should be in accordance, very well aligned with all the different sectors. Yeah, and somehow what we need is to promote some kind of easier procurement processes, just to implement all the politics that we want to develop in the close future, because otherwise it's not going to be possible to implement all the different solutions. I don't know if that answered your question.
Oh, sorry. No, the question was relating the timing to create a chain, like to move from raw material to recycle, recycle system. But basically, you can implement it in the real world solution.
Yeah, for me, it's really important. Yeah, if we're coming back to the digital passport, and I don't know who mentioned it during the presentation, I think this is something that should be implemented or assumed from the very beginning of the life cycle process of the infrastructure of the project, and so the whole life cycle of the infrastructure. So we should start bearing this kind of concepts from the very beginning, from the procurement process, bearing in mind, being all of us in the same position and talking in the same language, because otherwise it's not going to be possible just to link and to show all this value chain or these chains, considering the evolution of the materials and guaranteeing the circularity as a whole. Yes. I don't know.
Do we have other questions in the audience? So maybe I can ask one question to, it's for each of you. What is the one metric that will, that is, let's say, a metric or biggest blocker right now on your project? What do we have to do on, I don't know, tech, regulation, data, industrial adoption, and what is his biggest blocker, and what's your plan to smash it?
I think it's, you said it's to all of us, so I think from the life cycle assessment point of view, data availability is always a bottleneck and a hurdle. So we really have to work on the availability of data without neglecting the confidentiality and the, let's say, the understandable interest of the industry partner to keep it confidential. So we have to find a way that data can be used in an anonymized way, or at least in a certified way, without releasing them. So the exchange of data, and there was a reference also to Catena X, there's a good basis to exchange data, but we have to keep them in the interest party confidential, so we most likely need certification of data that they can be used without releasing details.
Yeah, we have here the availability of data. I would say in our case it's availability of secondary raw material, because I think the processes to use them are further than the supply chains of the materials, and I think that will be a big issue to build up the supply chains, to build up the circular waste streams, to get these secondary raw material back into the factories.
Yes, so one of the challenges what we are facing is basically the gap between the transparency and confidentiality. Okay, so like in the DPP, we are always thinking about the transparent data, okay, but the stakeholders or the user, so what is their confidential data and what is their transparent data? Okay, so these two, so we are always, so whenever we are talking about do you have the available data or not? Okay, so they said, okay, we have available, or they can, and whether they want to unlock this data or not. Okay, so that is the thing. This is one, and another what you say like the infrastructures. Okay, so we also, for the small stakeholders, for example, in our base project, if we are talking about the EVs and the big industries, so they have already their IT infrastructure and all other things, but for small industries, LMTs and industrial batteries, okay, they don't have this infrastructure to collect data from their upstream members, and also they have to track these data up to the downstream of the last end. Okay, so whether they have this capability or not, because the responsibility of the DPP is the organization who will put this thing in the market. Okay, so these are the different challenges we are facing. Yeah.
Yeah, I will say that there are two. One is, okay, how to translate potential co-benefits in the long term in money, in something that could be monetized. And the second one could be, okay, as you know, we are living a change of paradigm in construction. It means that, okay, we are not building for robust, we are building for robust, for circular, for sustainability, for social, and so on and so on. So at the end, we need a multi-criteria analysis that somehow has to include different weights, or at least ways to make this balanced. Maybe artificial intelligence could help on this and could be very useful for different administrations, owners, and so on, national growth authorities, etc.
If I may add another point, we have seen here quite good advances in, let's say, localized area. So we, in TranSensusLCA, we were covering the vehicle, and maybe then we go up to the on fleet level, and then we have seen here these circularity on vehicle level and so on. But what is missing is that we then bring this to the system level, that we can really analyze what is the impact on system level, what is the impact if we change in certain aspects, what are the consequences then for the whole transport system. So what is the impact of the new vehicles on the infrastructure, what is the impact on the circularity, then on the material flow within Europe in the whole system. And so to uptake this on a system level is also a challenge.
Thank you. Yeah, we have a question there, please.
Thank you very much. Nathaniel Douchier from SII France. Most of you have developed in your project methodologies, new methodologies for LCA, for example. Do you consider, while developing these methodologies, apart from the technical relevance, also the social acceptance from the people who are going to use these new tools or platforms? Or do you maybe consider that this is something that's important, that should go through regulation to be used all over the sector?
I assume this is a question to all. In our project, of course, we also have the social life cycle assessment, so the social aspect was inherent part of our proposal, and since we were compromised of so many stakeholders, of course, the practicability and applicability was also part of our project. So we did the road testing, we checked with practitioners if this is applicable. Of course, with the common public, we're not able to test this approach if but this is something I think in the future step, that once the industry is uptaking the methodology more and more, then we can see how it affects then the acceptance on user end user level at the buyers.
I think it's a very important question because when we think on our car, it's quite important that it is accepted, and the customer in the end will not compromise in quality or safety or something like that, and cost as well. So that's a quite a big challenge that you have to come into the requirements of the customer. And if we think especially maybe on plastics or something like that, no one wants that the plastic inside the car smells like it is like post-consumer recyclates or something like that. That's a very big issue, and there we have to find solutions because there is no compromise that is not accepted. And if it's not accepted, we can have the best technologies, we will not sell any car.
Yeah, so social acceptance of digital product passport, new thinking. Okay, so because it's already in the regulation, okay, so we have to think about the how we implement, not the acceptance, because transparency is one of the key issue here. Okay, but anyway, so whenever we develop this tool, we always think about this. Whatever is the software tools, okay, so we always think how they so how people think and what will be their behavior and all other things. So this is a normal protocol, but we have to think more about these things. Okay, and of course this should be other things. Yeah, we'll consider this thing.
Yeah, I will say that okay, the use makes you a master, and somehow the more we use, also the more deficiencies will we find to the system. But this is something that is a process itself, so I think it's absolutely necessary. And I think the clue, as said by Thilo at the very beginning when he talked about the ontologies, and I think the ontologies for cars should be, from my ignorance of course, should be the same as, for example, for a train, or somehow should be coherent, because one day maybe in thinking in transport infrastructures in the future, we'll have a new kind of transport that will be a mix of them, and we can be continuously changing. Could you imagine once again to reinvent the wheel with a new digital passport because we didn't define a good ontology? And for infrastructures, it's exactly the same. Somehow, what I try to explain or to develop for roads should be useful or in parallel to rails, and also to inland waterways, for water treatment, and so on and so on. So I think the clue is ontology.
I already have some good news. We did the analysis whether it's applicable to the other transport mode, and it's fitting.
Thank you. We have a question just in front. Jan, please.
Thank you. Ian Fire from Bosch. I have a question for ZEvRA, and it kind of builds on the comment from Thilo regarding system. And that is, I was quite impressed with how you're basically dividing up the vehicle into different pieces, and so plastics, metals, glass, things like this to recycle. The question that comes to mind immediately is, these vehicles are quite complex. They're made up of a lot of things, big things, small things. The real question is, how do you set the priorities? You can't do everything all at one time. So really the question is, can you set priorities to say where the low-hanging fruits, we take those first, and then we start moving up to the more complex problems? So a methodology that looks at this takes the challenge apart. Does that make sense?
Yeah, and I know that's one question regarding our circular design topic as well, because one big issue or one big topic is to reduce the complexity a little bit, because when we see the actual material mix, we have so many different alloys and so on, and we have to reduce the complexity to bring the solutions with the recycled material into the car. And of course, you have to go step by step with the first, you said, low-hanging fruits. There are some applications which are more easy to implement than other ones. So yeah, but I think it depends on the design topic as well as on the material and process topics.
Thank you. There is a question, really, the last row, please. Yeah, you have to jump.
Was it you? Yeah.
It's like in the
Thank you.
In the dark.
Shahin Jamali from Fraunhofer IEG. I basically wanted to make a comment rather than asking a question. I'm the coordinator of the BASE project, and what I wanted to mention regarding the social aspects is that we have gone one step beyond the normal social science aspects within BASE project, which very soon we want to also make a webinar out of, and that's understanding the whole value chain rather than what's happening inside the EU, but the whole value chain, when starting with the material exploration and excavation. So we have partners from Chile, Republic of Congo, and then how all these materials are being basically used and transferred within the value chain and ultimately used within the, basically within the EU. And we have, as Farhad was mentioning, we have more or less developed a system in collaboration with all these societies, so to speak, and social scientists from South America down to EU to somehow quantify the effects of manufacturing batteries, using batteries, and from the cradle to grave of the batteries within all these societies. And I really want to basically ask everyone to follow our page within the BASE project, and hopefully soon with all the experts, I'm not the one, we will be presenting how we have quantified these aspects and how it's going to have an effect within and outside of the EU, basically. Thank you.
To whom would you address this or statement or question, or someone want to answer? Take it.
I mean, no. The gentleman who was asking about the social aspects within the LCA, so basically that was as a complement to what was provided by the good panelists.
Okay.
Shahin is the coordinator of the BASE project. Okay, so he just answered one of the questions. Okay, that's that how the social impact is considered in our development. Okay, so we already said that we develop a social ESG indicators. Okay, so when we are developing the ESG indicators, so we have 72 variables. Okay, and then these are for different organizations, starting from the miners. So in our project we have also miners and CAM producers and then manufacturers and all the value chain members. Okay, so there how the sourcing is their ethical sourcing and environmental impact, and also how they govern. So so we selected 72 variables, and from there we created the indicators, which is called the social ESG indicators. Okay, that's what he said to you. Thank you.
Thank you. Is there any question in the audience? Not that much. No. One more question, that since all of you are kind of shaping different pieces of Europe's sustainable mobility puzzle. So we have seen LCA, circular EVs, battery passport, low impact infrastructure. Where do you see contradictions or gaps between your approaches? And how can your project better align to deliver a unified European vision, which is the final goal
Oh.
Maybe a tricky one, no?
Yeah,
a real question.
It's indeed a tricky one. As I said, the gap I see is really to bring all the puzzles together, to align it. You have seen the statement with the mining and the social aspects. So we have seen that for the circularity, there's also standardization needed. And somehow we have to overcome this fragmentation and bring all the different pieces together. And this is a significant gap. And even if we are sitting here together, there might be also different opinion and different views, which needs to be solved somehow.
Yes,
so we do need a common ground. And I think harmonization in the approaches and between the different projects is urgently needed. And we have to then really go to, most likely go in terms of research funding, maybe to go to bigger initiatives, as we are currently planning for FP10 with the flagships and so on. This is maybe an instrument which could overcome this fragmentation.
The kind of answer will be this flagship and big project and be strong
could
together.
Be. Yeah.
Okay. Thank you.
Yeah, what I agree what you said. The overall topics for me, it's like the direction we have with the question over there. We have some first applications, some first technologies, but it's quite a very complicated product. In the end, it's an emotional product, as we said, and we just want to show how some parts can be changed, but there are some more complicated parts which are more difficult than to change, to use recycled material. And I think there are some quite big challenges in applicating the technology, the use of secondary material for the whole car, for all applications. But our goal is to show that what is possible, that there are some solutions, and then if we go step by step, that we go step by step to cover the whole car in the end.
Thank you.
Yes. So regarding the circularity point of view, so in battery regulation and other regulation, what they're saying that in 2030 or 2034, some percentage of for example, cobalt or nickel, or this should be from the recycled content, right? So how we'll do these things? Okay, so if we really don't know where is the source from the recycler, okay, and what is the grade of that materials, okay, so these are the big challenges, okay, so even we know the recycler, but whether from where this sourcing, this the closing the loop, okay, this is a big problem. So I think from the base project, that if we develop this whole ecosystem, then we can able to find out these solutions, okay, and then the manufacturer can really understand from where we can get this recycled content, okay, so it will also improve the recycling efficiency or competitiveness of the EU as well.
Yeah, I would say there are two main contradictions or barriers, I say. One could be, for example, that, okay, we are promoting or we're developing solutions. We're living in an area that technology moves really fast. And we are trying to impact to a sector that has big inertia, so it moves really slow. And sometimes there is a misunderstanding between what we are developing and what the building sector is ready to accept or to assume. And the second one would be in terms of legal issues, because of course we are technology is fantastic, is always fancy, but then if you want to implement something, you have to talk with legal departments, yeah? And also this is something that sometimes technical people, we are not used of it, and it makes some difficulties into progress in this. Yeah. So I will say that it's not a contradiction, but it's more than a barrier. Yeah.
Maybe this goes hand in hand with the need that we have to speed up the implementation of innovation.
Yes.
So we are lacking definitely of speed in translating the good findings from the projects into real innovation and market uptake. And this is something which is also needed.
Yes. Yeah, you're right. So maybe I can ask you also, Beatrice, if you have some question or statement.
Oh, no, indeed. And actually, this last exchange was really in the direction of what I wanted to ask, because we talked about social acceptance a few minutes ago, and you've already actually hinted at a lot of issues right now that would maybe be blockers to get to this uptake of solutions. But that's actually what I'm wondering about. How can we increase industrial uptake? Obviously, in the consortium of your projects, you have a lot of industrial players, but as you mentioned, some of you mentioned these or hinted at these, it's maybe not the same people that are working in this project or have to make the decisions then to implement them. At the same time, we have really, if we go to the details, we have the issue on data sharing. And, whenever, for instance, we were developing the batteries regulation or, the process was still in place, the discussions, I remember this was a very big pain point for the industry, the data sharing, the sensitive data sharing. I'm wondering if the projects that are here presented, do you feel like there's an evolution in the acceptance, the willingness of the industrial players to uptake these solutions and being more open to harmonization, to data sharing? Have you seen an evolution there, or what do you think is still missing to get to that step, to bring these solutions actually to the market?
I didn't mention it in my presentation, but briefly. A good example, and we really made good experience with the road testing. That on a small scale within the project, we really went to the practitioners and did the testing of the methodology. And for the first time in my European career, so maybe for 23 years, we got input from the industry. We got data from ACER. We got data from the companies. And they really work together to test the methodology. And if you think about this, then this upscaling of this approach would lead automatically to sandbox approaches that will really demonstrate where the industry is getting together, putting their resources together, and test it in, let's say, in a sandbox approach. That really then will accelerate the uptake of solutions.
It's a quite good question. I think we have to just not more focus on the problems of the industry and try to involve the problems and the really needs they have into our projects before we start the projects. And I think that's this communication and interaction with the industry before starting proposals, before starting processes, that we get the needs. But if we address that needs, we can be more sure that they in the end will end up in the industry. And in the end, that's, I think, one of the biggest topic, to get even more interaction between the research and the industry before starting projects, to involve them, to get the really needs, and then there's more interest to bring that into the market, the results of the projects. That's, I would say, is the the best way.
For my side, I think that the data value, so how the industry try to develop some business model by the digital battery passport. Okay, so they don't need to, they try to know how DBP will improve their efficiency or reduce their cost. So these things we need to, so we are already discussing this thing to our use case partners. So what would be the different business model if they get the DBP and all other things. So we need to explore more about these things. Okay, so in order to uptake in the market.
I still thinking in the contradictions. But you give me the clue. The thing is that, yeah, you are lucky somehow because you are working in the private sector for private companies, but we are working for public sector. And I think just in the middle point is the solution, the public procurement procedures and all these things, because it's the only way to combine maybe both possibilities, because how can we make a business model for the public sector? You know, it's like the trick is there. Yeah? So maybe if we think in PPP is the way to move forward in this direction.
Maybe just looking around the room to see if there's actually one question there.
Okay. So this is a question for Professor Bein. To my understanding, TranSensusLCA also looked at battery recycling. Today, I think one of the issues of battery recycling is there aren't many batteries to recycle yet. And so setting up a recycling industry would be expensive, at least in the beginning. It's quite difficult to talk about business models at the beginning. So my question is, do you think society is ready to accept, in Europe, a higher cost for components that have recycled content in them? Or do you think, I mean, which is the way to go forward to make it cost effective? Do you think subsidies are required to start up the recycling industry at the beginning?
David, that's a very difficult question to answer. On the one hand side, everyone in the room can answer the question for yourself. Are you willing to pay more if the product is environmental friendly or not? I would assume, we already heard it, most of the customers would like to have a better performance for the same price, for the current price. That has consequences on the technology. So in terms of recycling, better recycling and so on, I think we have, in the future, we have to manage the material flow, the recycling, even the reuse, the second life, in a way that it is cost neutral. That requires much stronger automation and the application of digital tools. On the other hand, that's why we also developed TranSensusLCA. We have to convince the end users that if they're buying environmental friendly product, there's also win situation for all. It's not only environmental friendly, it's also strengthening the competitiveness and so on. And this is requires a common effort for all of us. Personally, for me, I think I also have to reflect my own behavior, but we have to give them also the choices. Does this answer your question? A little bit. It was, yeah.
Yep. No, thank you very much to the audience as well for the questions, and thank you for the presenters for the very interesting insights. I think there's quite a lot that we can take away from this session, and interesting to see that even if we have 4 projects that have fairly different scopes of action and of focus, we can still see some overlaps on the challenges and on the opportunities that are ahead. And I will definitely take the point on the need to bring R&I and the industry closer and bring this dialogue much, much closer to bring the solutions into the market. So I really will bring this one with me. I would like to then close the session if there's no other questions. Thank you very much for attending, and a round of applause to the speakers and the moderator. Thank you.
Thank you.